Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to demonstrate for you how to solve quadratic equations by completing the square. So we're going to look at these two examples here and here. We're going to take them one at a time. Now the first step in completing the square, right, unlike other methods like factoring or using the quadratic formula, you typically don't want a zero on one side. Usually move the constant over. So I'm going to go ahead and do that by adding 27 to both sides. And you'll notice that I've left some space. And the reason is what we're going to do is we're going to figure out what can we add to this left-hand side to make the left-hand side a perfect square. The key in understanding this has to do with understanding the FOIL method when you multiply, right? Because this is a 1x squared, we're going to try to factor this into x minus something times x minus something. Now the reason for the minus signs is because this is -6. Now remember that the outer and inner terms have to give you this -6. So these have got to be 3's. So that you end up with minus 3x and then minus 3x gives the minus 6x. Whatever values go here and here, it's always going to be half of whatever this is. Now, remember though that the last product here in the FOIL is going to be plus 9. So in order for this to equal this, we need a plus 9 here. So we'll go ahead and fix that by adding 9. Now, anything you do to the left-hand side, you have to also do to the right-hand side. So you figure out what to add by looking in front of the x term, take half of this, square it, add it to both sides. This now, by design, factors into x minus 3, the quantity squared. I'm going to go ahead and write it like that. Equals, right-hand side, 27 and 9 is 36. All right. Next step, square root both sides. Keep in mind, though, that in this equation here, it's x minus 3, the quantity squared. So x minus 3, if you square that and get 36, x minus 3 could equal 6. Or -6. So what I'm going to do is put plus or minus 6 because either of these squared is equal to 36. I'll go ahead and add 3 to both sides. And we have our two solutions. X could be 3 plus 6, which is 9, or x could be 3 minus 6, which is minus 3. All right, so that example's done. I think what I'll do here is shrink it down a little bit, or move it over. All right, we'll take a look at this one. So let's kind of move this center stage here. All right, so this example. This one's got a couple things that we have to kind of take care of first. First thing we're going to do is add this 12 to both sides. Next, when you complete the square, you want this to be a 1 in front of the x squared term. So the step that'll do that for us is to factor that 2 away from these two terms. And I'll leave some space for adding. Now this type of factoring might seem a little strange because 2 is not divisible by 5. However, just check it out. 2 times x squared, there's your 2x squared, and 2 times 5 halves times x is 5x. So now what we're going to do is we're going to look right here, just like before. We're going to take half of this. That would be 5/4. I'm going to go ahead and write that down. Got an extra thing there. I don't seem to meet. I don't know how that ended up there, but 5 halves x. All right. So we're going to look right here, take half of that, be 5/4. I'm going to write that down. Square it, that would be 25 over 16. So I'm going to go ahead and add 25/16. Now, when we add something to the left to maintain equality, we're going to have to do something over here now. And the other thing you got to be careful of is we didn't actually add 25 over 16 because remember, there's this 2 sitting in front of this. What we actually added was the product of the two, which is 50/16. So I'm going to go ahead and add 50 over 16 to both sides. All right, don't really need this stuff anymore. Okay, so we've maintained equality. This now by design factors into x plus 5/4, the quantity squared. Remember, because that last product's got to give you this. Right-hand side, how about we just write that 12 times 16 plus 50 all over 16. But I think what I'll do here is, because I don't feel like multiplying that out, Okay, so this is 242 over 16. All right. Next step to solve this, let's divide both sides by 2. So we're going to have x plus 5/4, the quantity squared, equals, this is now 242 over 32. Then we square root both sides. Maybe before we do that, maybe we simplify this up a little bit. Give me a moment here. Oops. I guess we'll just do this. At least divide. We'll divide a 2 out of it anyway. All right, so dividing both these by 2. All right. Now we'll square root both sides. So we're going to have x plus 5/4 equals plus or minus square root of 121 over 16. And I think what I'm going to do here is just put a decimal there. I get 2.75 for the square root of this, so I'll put a plus or minus 2.75. Subtract negative 5/4, so x is going to be equal to minus 5/4 plus or minus 2.75. And I'm going to just go ahead and calculate values here. So we're going to have 1.5 for one of them, and that would have came out to 3/2 had I kept this in fraction format. Oops, did that one twice. And I get or x equals 4. So I got a little lazy here and didn't feel like dealing with the fractions. This one would have worked out very nicely. This would have been, had we left it in fractions, 3/2 and 4. But anyway, the purpose of this video is to demonstrate how to complete the square. I hope that these two examples help with that. Have a great day.